We have discussed the vascular events and cellular events, and we have already um, brought, we have already called our policemen, neutrophils, and WBCs from the blood to the area of inflammation. Okay, in our example, our hand was inflamed. Our hand was inflamed, and there was fight going on between some bad bacteria. These are the bad bacteria, and our tissue was severely injured due to these bacteria. And our tissue, it secreted various chemical mediators like histamine and nitric oxide, bradykinins, leukotrienes. These all are the chemical mediators of inflammation, and they send the message to the arterioles, and they created arteriodilation, and they brought more and more blood in the capillary network, and the exudation was happening, and that created hemodialysis. It created hemoconcentration, and that created RBC clumping, and WBCs were marginalized, and WBCs finally, with all those struggles, WBCs first neutrophil come. Okay, first neutrophil come. Okay, let me say neutrophil only. Neutrophil, now it entered the many neutrophils, they entered in the area of inflammation. Now what happens? Now I was telling you, how do these neutrophils recognize this bacteria or any offending agent, maybe fungi or anything. In our example, it's bacteria. Okay, in our example, it's bacteria. It can be anything. So how do these neutrophils recognize this bacteria, and how do they destroy? These all things we'll discuss in this particular video. So now our neutrophil is already now recruited. This is called recruitment of neutrophil. This is called now neutrophils have been recruited. This is called a oh my god, neutrophil recruitment. Okay, now neutrophils have been recruited. Okay, now how do these neutrophils recognize? There are many receptors. It's all about receptor. Okay, it's all about receptors, this and that. Now the receptors that are present in the neutrophils for the recognition of offending agents, these includes, one number is toll like receptors. Second one is G protein coupled receptor. Third one is scavenger receptor, and last one is receptor for opsonins. Now I'll discuss in detail about what is opsonization. See these neutrophils, they are very difficult to deal with, because they need testy bacteria. But as we know, bacteria, they are not testy. They are not testy. So to make the bacteria tasty, to make the bacteria look delicious, our body system does one thing that's called opsonization. Now what is opsonization? Opsonization is the process of coating the bacteria. It's the process of coating the bacteria or any offending agents or any foreign particles. The opsonins, they coat. Okay, now what is the importance of opsonin is they facilitate recognition and phagocytosis, both recognition and phagocytosis. That means now these are the bacteria, these are our very dangerous, very bad looking, badass bacteria are there. Now there are opsonins. These are opsonins, they coat these bacteria. I'll give some examples of opsonin too. They are also important in Viva and MCQs. These opsonins and those chemotactic agents are very important, okay, for Viva. Now opsonins can be example, I'll give few examples of opsonin. Fc portion of IgG. Okay, this thing you'll discuss in microbiology. Okay, the function of IgG you'll discuss in microbiology. What is the function of IgG is? One of the function of IgG is opsonization. Second one is complement system. I think we have discussed complement system as well. Complement system product C3b. What was C5a? C5a was chemotactic agent. It was chemotactic agent, but C3b is an opsonin. And a plasma protein, that is collectins. Collectins are another plasma proteins. They are also responsible for opsonization. So now what do these opsonins do is they will coat the bacteria or any offending agent. So as now our hero, these neutrophils, now what do they do is they will now easily engulf. Okay, they will now easily engulf these bacteria. Now there are three processes now. First is recognition. We have already talked about recognition. How do they recognize? They recognize by these receptors. This is recognition. Second one is now engulfment. Now how do they engulf? They engulf, now you know very well, they engulf by endocytosis. Okay, they can also engulf the bacteria by receptor mediated endocytosis. Simply endocytosis or receptor mediated endocytosis. That means what? There are receptors. I have already discussed toll-like receptors, GPCR, scavenger receptors. These receptors, now the bacteria will bind, which is coated by opsonins. Now this WBC will, now what does it do is it will engulf like this, engulf the bacteria. See, there is one misconception, only the macrophage engulf. No, WBC's leukocytes also engulf. Okay, leukocytes also engulf. Okay, now we have already engulfed the bacteria. Now see, now the bacteria is inside the WBC. Now it is inside WBC. Now this is the nucleus. Okay, and now this is called phagosome. The thing which has been phagocytosed is known as phagosome. Very simple. Whatever you eat, that is phagosome. Whatever the WBCs eat, that is known as phagosome. Now they fuse with the lysosome. And they form phagolysosome. It's like a story. Okay, it's very, very interesting. It's like a story. Now they form phagolysosome. Now they need to be killed. For killing, now we have two processes. That is called intracellular phagocytosis. Now okay, I'll just recap. Maybe it's going on from the top of your head. See, from up to previous lecture, we have discussed the neutrophils were already inside the tissue. Now the neutrophils need to recognize the bacteria. For the recognition of the bacteria, there was opsonization, the coating of the bacteria. Now the bacteria has been coated like this. Okay, now they need to be recognized by the neutrophils. Okay, for that there were these receptors recognize the bacteria. These bacteria bind here and they recognize. These bacteria bind here and they recognize. Okay, now not only recognition, they need to be now phagocytosed. They need to be what? They need to be phagocytosed. That is called engulfing. Now they engulf. Recognition already done. Now they engulf. Now they are already inside the leukocytes. They are already inside the WBCs, or they are already inside the these neutrophils. Okay, now these neutrophils, now they will kill. That is called intracellular phagocytosis or intracellular killing also, you can say.